Okay, the next section is 7.1. We're going to be using trig identities today. So hopefully you can recognize and write fundamental identities after today and use these to evaluate trig functions, simplify trig expressions, and rewrite trig expressions. We'll even develop our own identities and solve some trig equations as well. So here's the first stuff you need to know. Now, I put some of this stuff on the formula sheet. I put this on the formula sheet, and that's it. So the rest of the stuff you're going to have to memorize. So we know, hopefully you know SOHCAHTOA at this point. All right, so you know that sine is opposite of our hypotenuse. So what you need to know now is that cosecant is the reciprocal of sine. So what that means is cosecant, if I want to write it out based on this right here, cosecant of some angle, we'll say angle u like they're using here, is going to be equal to hypotenuse over opposite because it's the reciprocal of sine, as you can tell from right here. So you have to know that sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent, or vice versa. Now an easy way to remember this is that every pair has a co in it, so obviously tangent and cotangent go together, but then these two are easy to get confused, and the way to keep them straight is that one of them has a co in it. So you know, this pair, the co is in the cosecant, and in this pair, the co is in the cosine. So then you can rewrite these like I said. You can write cosecant is the reciprocal of sine, so you can go both ways with this. And then the quotient identities, you have to know that tangent sine over cosine, and then also then cotangent is the reciprocal of tangent, so you would just flip that if you want to get cotangent in terms of sine and cosine. Okay, these Pythagorean identities we're also going to have to use, but like I said, they are on our formula sheet, so you're not going to have to memorize those. Okay, these cofunction identities are things we're not going to use as much. These basically say that the sine of 90 minus the angle is equal to the cosine of the angle, and that comes actually from a right triangle, because if you call this angle u, this would be angle 90 minus u. And so, you know, if you label this side A, this side B, and this side C, for example, then what you have is the sine of this angle up here, 90 minus u, would be opposite over hypotenuse, so it would be A over C. Well, if you look at cosine of angle u down here, then cosine of u from this triangle would be adjacent over hypotenuse, which is also A over C. So you'll notice that they are the same. They're complements of one another. Basically, these are complementary identities from the fact that cosine and sine are really just ratios of a triangle. So all these identities hold true. We won't use those as much, though. We won't use these as much either, but we learned about even and odd functions earlier in the year. If you remember on the formula sheet, what we said is an odd function has this property, where when you stick in a negative sign into the function, you get opposite the function back. So this is supposed to be a negative sign right here in front. And then we also learned that for even functions, when you stick in a negative x, you get out the original y value back. So this was odd and this was even on the formula sheet. And those, you know, have properties as far as the general shape. One's reflexive, so the even is reflexive around the y-axis, and the odd functions are rotationally symmetric by 180 degrees. That's true with sine and cosine. So sine, we're going to find out, or we already did, is odd right here. That's what they're telling us. And that means you can rotate it 180 degrees and it'll land back on top of itself. And then cosine is even, which means that it's symmetric. So if I were to draw the cosine, you know, this point over here, if I reflected it over the y-axis, would land on this point over here. So, and that's what this says right here, because it's saying the same thing as this. When you plug in a negative x, you get out the regular y value again, so you get the regular function back. Okay, so let's just do some examples of problems that I'm going to ask you to do based on this stuff then. So the first is, I'm going to give you some clues about where an angle is, and you're going to have to write the 6 trigonometric functions of that angle. So let's use these clues. The first clue is that secant, which is really 1 over cosine of u, equals negative 3 over 2. I can flip that if I want and make that cosine of u equals negative 2 over 3. So I flip both sides. Or you could cross multiply, however you want to solve this. But what that tells me then is I also know that the tangent of u is positive. So what that means then is if the cosine's negative and the tangent's positive, that means the sine must be negative, because tangent's really sine over cosine. So we have sine over cosine being positive. We know the cosine's negative. Therefore, the sine must also be negative. So that puts us down here in the third quadrant where both the sine and the cosine are negative. So I'm going to draw my reference triangle there. This is the key, setting up your reference triangle. The cosine of the angle is -2/3, so that this would be -2, this would be 3, in which case I can do the Pythagorean theorem to find this length over here. And this gives me the square root of 5, and I'm going to make it negative because technically I'm going back and then down. So when I want to find the other trig functions, I can do the sine of this angle, we call it u, which technically used this angle, but it doesn't matter, we're going to use our reference triangle right down here. So the sine of u is opposite, which would be negative square root of 5 over hypotenuse. The cosine of u, they already gave us, is -3/2. The tangent of u is opposite over adjacent, which is square root of 5 over 2. The negatives cancel. And then I can do the reciprocals of these. So we have cosecant of u equals 3 over negative square root of 5, or I'll put the negative in the numerator. And then cosine, the reciprocal of that, secant, which would be -2 over 3. And then I also have cotangent, which would be 2 over square root of 5. Okay, the next one wants us to simplify a trig expression. So to simplify these, we're going to do things like factor. So if we factor out a sine of x, we get cosine squared of x minus 1. And then we can actually look at the Pythagorean identities that we gave. One of the Pythagorean identities that I just gave you was the sine squared of x plus the cosine squared of x equals 1. And so if I subtract 1 from both sides, I'd get, and then move the sign over to the right as well, I get negative sine squared of x equals cosine of x squared of x minus 1. So I can substitute this in right here, right here. This would be negative sine squared of x. So this turns out to be negative sine cubed of x. And that's a little bit simplified, but it must be the same thing as this. If you were to graph these in your calculator, you would get the same function. All right, we can rewrite things like this as well as another example. This is a little confusing, but to do this, we're going to multiply, kind of like we did with complex numbers, we're going to multiply by like what we would call the conjugate, where you just change the sign in the middle. So it's 1 minus sine of x times the top and the bottom. This gives you 1 minus sine of x over, and then when you FOIL the bottom now, the middle terms are going to cancel. So you just get the first, which is 1 times 1, and the last, which is negative sine squared of x. From here, this is really, if you look at your Pythagorean identity again, which is sine squared of x plus cosine squared of x equals 1. This is, if you subtract sine squared from both sides, really just cosine squared. So I'm going to write this as cosine squared of x. So now I have 1 over 1 minus sine of x over cosine squared of x, which I can make 1 over cosine squared of x minus sine of x over cosine squared of x. So I'm going to try to rewrite this now. This right here, the reciprocal of cosine is secant, so I can make that secant squared of x. And I'll make this sine of x over cosine of x times 1 over cosine of x, because I can rewrite this as, this is the tangent and this is the secant. I know that's confusing. We'll have to practice these things, but we didn't necessarily simplify this, we just rearranged it. And we got something where we got rid of the fractions and we have another trig expression, which is exactly identical to the original that we started with. Now we'll have to try a lot of homework problems and practice this stuff, but hopefully we can make some sense of this.